Lesson 2.1, Task 1. Investigate solutions of simple quadratic equations. Recall that a number x is the square root of a real number a provided x squared equals a. To solve for the square roots of a graphically, graph f of x equals x squared and g of x equals a on the same coordinate plane. The real square root of a, if any exist, are represented by the x values of the intersection points of the graphs of f of x equals x squared and g of x equals a. All right, for parts A through E, use a graph to consider how many real solutions exist for any simple quadratic equation. All right, so what are the solutions of each equation? So we have x squared equals 9. If we take the square root of both sides, we get plus or minus 3. So that one matches with this one. And then if we take the square root of 12, we're going to get plus or minus the square root of 12. And then if we do the square root of 0, we just get 0. There's not a plus or minus. 0 is neither positive nor negative, so we just get one solution there. And if we take the square root of negative 1, we get an imaginary solution, so there's no real solutions. That means there's no point of intersection for this quadratic equation. All right, so it says consider the equation x squared equals 9. How does the graph represent the solution? All right, so when you take the square root of 9, you get plus or minus 3. So it should intersect the x-axis at both 3 and negative 3. So let's see what it says. It says they occur at the points of intersection of the functions f of x equals x squared and g of x equals 9. So if you graph this and you graph this, you're going to find the intersection of the two graphs. We've done that previously, I believe. All right, so it says consider the equation x squared equals 12. Does the graph allow you to determine an exact solution? Explain why or why not. All right, so if you take the square root of 12, that's going to be an irrational number. It's not a perfect square, so it would not be an exact solution. It would be an approximate, so you would have to round. So let's see what it says here. They are irrational numbers, so they can only be approximated from the graph. So again, it would just be an estimate. All right, it says consider the equations x squared equals 0. What characteristics of 0 distinguish it from other numbers? All right, again, it's not positive or negative, it's just 0. So it means there's only one possible solution. All right, consider the equation x squared equals negative 1. Explain your reasoning for the solution. All right, so if I graph x squared, you know it's the parent function, and it goes through the origin, and it's a U-shaped graph facing up. If I graph negative 1, it's a horizontal line through negative 1, and this U-shaped graph would not intersect with negative 1, which means there's no point of intersection, there's no solution. And also, if you take the square root of both sides, the square root of negative 1 is imaginary, so there's also not going to be a solution. It says there are no points of intersection, so there are no solutions to the equation. All right, consider the equation x squared equals a. What can you conclude about the number of solutions? There will be blank solutions when a is positive. All right, there will be 2 solutions when a is greater than 0. All right, there will be blank solutions when a equals 0. All right, when a equals 0, it touches at one point. Remember, 0 is not positive or negative, but it does intersect at one place. And this last one says there will be blank solutions for a less than 0. So when a is negative, there are no solutions. All right, so for a quadratic equation, as we've studied previously, you can get 2 solutions, 1 solution, or no solutions, and that all depends on what the a value is. All right, explain your reasoning. We just did that. All right, Ariana is looking to purchase a square painting that will fill 10 square feet of wall space. Write and solve a simple quadratic equation to find the side length of a square painting X. Explain your reasoning. All right, if you have a square is length times width, like a rectangle, but a square has equal sides. So you can just say x squared equals 10 and then solve it from there. So x squared equals 10 would be your equation. To solve it, you would do square root of both sides. Or you could graph x squared and you could graph 10 and see where the 2 points intersect. Let's see what they put here. All right, the area of a painting is x squared, so you can solve the equation x squared equals 10. Based on the graph, the solutions are approximately negative 3.16, which wouldn't make sense. If you're talking about the area, it has to be positive, so 3.16. So the negative solution doesn't make sense, so the side length of the painting is approximately 3.16 feet. All right, that's all for task 1. If you have any questions, let me know. Lesson 2.1, Task 2. Investigate non-real solutions of simple quadratic equations. You saw that x squared equals negative 1 has no real solutions. It does, however, have solutions that are not real numbers. These solutions are expressed using a number I such that I squared equals negative 1. Then I is a solution to the equation, thus I is the square root of negative 1. When you take the square root of a negative number, the result is called an imaginary number. The equation I squared equals negative 1 has two imaginary solutions. X equals plus or minus I. All right, so imaginary unit, I equals the square root of negative 1. This is important. All right, so imaginary numbers have the form Ri, where R is a non-zero real number and I is the imaginary unit. Consider the equation x squared equals negative 4. The solution steps are shown. So you have x squared equals negative 4. So if we take the square root of both sides, we get plus or minus the square root of negative 4. And then you can separate 4 into two parts. Negative 4 can be rewritten as 4 times negative 1. We know the square root of 4 is 2. And now we know that the square root of negative 1 equals I. So x squared equals 4 equals plus or minus 2, and x squared equals negative 4 equals plus or minus 2i. Just a slight difference for an imaginary number. All right, so it says, how are the solutions of x squared equals negative 4 related to the solution of x squared equals 4? So they are related by a factor of I, your imaginary unit. All right, so it says select all that apply. What are the solutions of x squared equals negative 9? So that would be 3i and negative 3i. How can you demonstrate that your answer is truly a solution? Okay, so you can just plug it in. You substitute it into the original equation and solve it to check it. All right, it says, how are the solutions of x squared equals negative a related to the solutions of x squared equals a? Again, they're related by a factor of I. Okay, so that's the only difference between x squared equals negative a and x squared equals a would be the imaginary part. All right, that's all for task 2. If you have any questions, let me know. Lesson 2.1, task 3. Investigate non-real solutions of simple quadratic equations. To determine the type of solutions a given equation will have, rewrite the equation into the form x minus k quantity squared equals a. Some equations are categorized in a table below. All right, so if you have two real solutions, this number has to equal a positive number. As you can see, there's a negative 3 here and a negative 2 here. So before you take the square root, you would have to divide both sides by negative 3. Negative 2 divided by negative 3 gives you a positive 2/3. This one's already positive 1, so then when you take the square root of those, you would get two real solutions. All right, 0 divided by anything is 0. Take the square root of 0 and you're going to get one real solution. If you divide, or if you take a square root of a negative number, you're going to get two imaginary solutions. Again, the second one here, you'd have to divide by -2 first. 1 divided by -2 is -1/2, which is a negative number. The square root of -1/2 would be an imaginary solution. So all three of these equations would produce two imaginary solutions. How can you classify the solutions of each equation? All right, so this one equals +2. And since this is already isolated, that means you just have to take the square root. So since that's a +2, I'm going to have two real solutions. Before I take the square root, I have to divide by -2. 8 divided by -2 is -4. So then I have a squared term equals -4. When I have a negative number, it's going to produce two imaginary solutions. All right, and it kind of explains that here. All right, the next part says, how can you tell if the solutions are real? Explain your reasoning. All right, again, if the number on the end, I think previously it's called A. All right, so if this number A is positive, then it's going to produce two real solutions. If this number is negative, it's going to be two imaginary solutions. And if this number is 0, it's going to produce one real solution. All right, so it says give a value of A. That will ensure that the equation has exactly one real solution. All right, so that would be 0. Explain your reasoning. Well, that just comes from the definition above up there. 0 divided by anything is 0. All right, is it possible to have only one imaginary solution? No. If you have a negative number, you're going to have plus or minus something I, and it's always going to produce two imaginary solutions. So let's see what this says here. It is not possible to have only one imaginary solution. All values of A other than 0 have two possible square roots. So it'd be two real or two imaginary. So, all right, select all that apply. What can you conclude about the number of solutions for the equation here? All right, before we take the square root, we would have to subtract C and then divide by B. So it says there's an infinite number of solutions. That's not true. We know it's 2, 1, or 2 imaginary, so we can rule out that one. There will be two solutions as long as A minus C does not equal 0. Okay, so that will be true because if I subtract C, A minus C, as long as that number is not 0, even though I still have to divide by B, we know it's going to be at least two solutions. We don't know yet whether they're going to be imaginary or real, but we do know there will be two solutions. There will be two imaginary solutions if A minus C divided by B is less than 0. So if this number is less than 0, if it's negative, square root of a negative is imaginary. So why does it say A minus C over B? Because I'd have to subtract C and then divide by B first to isolate the square root. So this one is also true. Because we know if it's less than 0, it does produce two imaginary solutions. All right, so the number of solutions cannot be determined from the information given. Well, we can determine whether it's 2 or 1 by the information given, but maybe not any more closely than that, but we'll keep reading. There will be two real solutions if A minus C over B is greater than 0. Okay, that one is also true because we know if this number is positive, it's going to produce two real solutions. And it says there will be 0 solutions if A minus C equals 0. All right, so that's not true because it would produce one real solution. So that would be the last answer. So not 0. If you get 0 as your answer, then that produces one solution of 0. So you have 4 correct answers there. If you have any questions on task 3, please let me know.